Hello everybody, welcome to part 2 of my Rack Tour 3 server Jamboree video setup. This one's subtitle is Hypervisors, VMs, and WANs, oh my. So this is something that was requested in one of the comments, but is also something I've wanted to do for quite a long time, where I go into detail about more of the, for lack of a better word, virtual parts of my home lab. You know, I've covered hardware in the previous video, so if you haven't seen that, I recommend watching it before watching this one. But in this video, I'll kind of cover basically 4 main sections of my network that video didn't cover. So part 1, I'll go over the hypervisor manager I use, which is a custom solution I built. Part 2, I go over the VMs and the services I run and provide for my users and myself. Part 3, I'm going to discuss briefly a little bit about my Home Assistant home automation setup, which I think is pretty cool and is kind of one of the core uses of all of this infrastructure. And part 4, I'm going to discuss my routers and how my crazy redundant WAN setup is put together and how that works. So stay tuned and we'll get started with part 1. So the first section here is on my PVC Hypervisor manager. So this is a custom solution that I wrote, and to kind of quote the tagline I put on the project, PVC is a Linux KVM-based hyper-converged infrastructure virtualization cluster solution that is fully free software, scalable, redundant, self-healing, self-managing, and designed for administrator simplicity. So basically it takes in, or you give it, physical servers running a semi-customized Debian base operating system, and it provides a unified cluster on top of those servers for KVM virtualization with all of the batteries included. So that's your storage, networking, and management. Now I have a link here to the main docs page. If you do find this this part interesting, or you find this to be a solution that you think might be useful for you, I definitely recommend checking it out. That link provides, all the information you'll need to kind of get started, and the code itself is all over my GitHub page. So the motivation for this solution really came back, several years ago, back in like 2016, 2017. I was running first a solution based off Zen, and then I was running a solution based off CoroSync and Pacemaker to manage KVM VMs. And as anyone who's ever used CoroSync knows, that's a pain in the butt. If you restart it, everything terminates, so that wasn't very good. And I looked at, and I'll get a bit more into how this compares in a second, but I looked into Proxmox. I didn't like it. There was a lot about that solution that I found really janky, for lack of a better word. It didn't really do what I wanted in terms of redundancy and resiliency. So I decided, something doesn't exist in this space right now. I'm going to create my own. So what PVC actually does, you can kind of look at it from 2 different directions. On the first side, coming at it from more of a home lab type side, it is kind of similar in a sense to Proxmox in that it's a virtualization solution. So it lets you run, as I say, Linux KVM based virtual machines on top of it. But what it really does differently is that redundancy and resiliency is baked into the solution at every layer. So it really is designed from the ground up to support the idea of it being a cluster rather than just a single server that happens to have some clustering capabilities tacked onto the outside of it. And thus, it's able to do things like seamlessly tolerate a single host failure with the absolute minimum of administrator intervention and, management of it to do that. And then it also kind of bridges a gap between that solution and then the kind of higher end, as I call it. So you have solutions like OpenStack. They're just these crazy, complicated, monstrous solutions that take, a team of 5 people a year to implement just to get a VM going. And also some of the proprietary solutions like VMware and Nutanix, they're just extremely expensive. So I really based PVC off of how Nutanix worked and what they provided as a solution, only instead trying to be a free software version of that. So you get those kind of benefits of a hyper-converged solution with high scalability, high redundancy, but for free. So moving on here, there's several parts to the PVC system. So on the virtualization layer, It uses Linux KVM and the libvirt management library, and this is what takes care of actually running the VMs. And it gives you some nice features like live migration between nodes, and a very wide guest operating system support stack. So it's able to run basically any VM, any guest OS you could possibly throw at it, from every flavor of Linux, Windows, BSD. Heck, you could probably run crazy stuff like Plan 9 or BOS on it if you really wanted to. The next layer is kind of the storage. So it leverages Ceph, and specifically its RBD Rados block device layer that gives virtual block images to run the actual VM storage on. So it uses pooling, puts a bunch of disks together in the various hosts, and then puts a pool on top. And in the default config, we're using a setup that in Ceph terminology is size equals 3, min size equals 2, and a host level failure domain. So what that actually means is, for every block of data that's written to the storage cluster, it'll write 3 copies of that data, ensure that those 3 copies are on different hosts rather than just different disks. So while you could lose a disk and recover from that, you can also lose a whole host and recover from that. And min size equals 2 means that the cluster will be live as long as there's at least 2 copies available, either read or write. So you can lose an entire host and the cluster is still fully functional. And then those RBD images provide shared storage, so you're able to seamlessly live migrate VMs across the nodes. On the networking side, it's leveraging IP Route 2, which is kind of the basic Linux, IP stack at this point. And then for client networks, we're using both bridges, so you can do VLANs on a switch kind of idea and bridge those into VMs. And we're also using FR routing, which is a descendant of GNU Quagga, to do both VXLAN private networks. So those are just virtual networks between the nodes that VMs can be placed into, and they don't have to actually exist as a VLAN on a switch. You don't have to have any control over the switch for that to work. And that FR routing also enables BGP route learning for upstream routers if they need to access those private VXLAN networks. Database side, there's kind of 2 parts to this. The first is Apache Zookeeper, which is the main state database. So Zookeeper is it's a redundant, always consistent key value store, and that's sort of the glue that holds the entire cluster together. Everything for the API, the daemons, everything talks to Apache Zookeeper in order to keep track of its state, and any state change is written to Zookeeper and then read out of Zookeeper. And that ensures that everything is, consistent with each other. All the nodes are in sync and all of that. We also make use of PostgreSQL for some additional relational database functionality that mostly is used by the provisioner that I'll get to in a second. Management is done, it's all Python based, so the whole daemon stack is written in Python 3. And then for management, there's both a Flask API, which provides the API interface into the cluster to do things with it, and there's also a Click CLI client that's provided that is an API client, so you can use a CLI tool to manage the cluster. There is eventually planned support for a web UI, but I'm not a front-end developer. I'm not very good at it, and it hasn't been a priority for me. So that'll eventually come, but for now it's CLI only. And the last core feature here is a built-in provisioner for creating new VMs. So this is a function of the tool that allows the creation of these highly flexible configuration profiles where you can put together various pieces of what are the CPU counts, what is the RAM count, what are the disks, what are the networks, and then combine those with a set of customized installer scripts, which you can use to write an installer for basically any operating system you can think of that you can, install from a Linux shell. And then finally, cloud init user data using an Amazon AWS EC2 compatible cloud init interface to push data based on the profile into the VM for future use. So now I want to go on to my implementation of the PVC Hypervisor Manager. So my cluster is kind of, I briefly mentioned a second ago that I actually use this with my employer and we have clusters in production. But I originally built it for my own home lab, and I call it a home lab, but it's also really my home production. and I use this cluster both as testing the solution as well as for running all my stuff. I did briefly mention in the previous video that I have plans to run a testing cluster, and this is what it's for, so I can actually test changes to this solution without impacting my own production cluster. So my setup is kind of the bare minimum of what a PVC cluster can do, or can be configured as, which is 3 nodes. It's basically impossible to run less than that, because basically all of the tooling needs some form of quorum, and the smallest possible quorum, without getting into the crazy math of like the 2 generals problem and unsolved problems in computer science. The smallest quorum is therefore 2 out of 3, so 3 nodes is kind of the minimum. Theoretically, you run it with 1, but you have no redundancy, so what's the point? All of my nodes here, they're Dell R430s, so they're PowerEdge, they're like short depth little nodes. And each one has one Intel Xeon E5 2683 V4 CPU. That's 2.1 gigahertz base and 16 cores and 32 threads. Each node has 128 gigabytes of DDR4 memory, 2 200 gigabyte Intel DC S3700 SSDs for the system disks. And PVC is kind of intensive on its system disk. It's got a lot of data that's being written, for that Zookeeper database and all of that, so it does need some pretty robust disks. And last but not least, it has 2 800 gigabyte Intel DC S3700 SSDs for those Ceph storage disks for all the VM data. So put together, that gives me a total usable resource amount using the n-1 number. So if I were to lose 1 node, how much do I have with just the remaining 2, which is kind of your like safe max, of 32 cores and 64 threads of compute, 256 gigabytes of RAM, and roughly 3.2 terabytes of VM data. So it seems like a decent amount, and it is, and it's perfect for what I do with it. You can scale up a much higher than this for a cluster, and even scale into more than 3 nodes, but this is perfect for my home lab. Lastly, and I again mentioned this in the last video, there's dual 10 gig networking to each server, and that's plenty of bandwidth for both the storage and cluster interconnects, so all that data that's flying around for the storage and live migrations and all of that stuff, as well as the upstream access into the VMs. So my cluster has a total of 57 VMs, which is actually a lower number. Even up to last year, I had somewhere in the order of 80 VMs, but I was able to really slim that down, kind of get to my core services, and really just sort of optimize what I was running. And 57 is a pretty good number for me. It balances well across the cluster. And individual VMs, their resource uses range from small to quite large. I'll show in a moment when I go into the live demo, but I have some very small VMs, some very large VMs, a little bit of everything in between, and they all kind of balance together. So yeah, now it's time for a brief live demo. I'll show off some of the functionality of the PVC CLI and my own cluster, and show you what it can do. So jumping into my terminal here, I can kind of show off a little bit about the PVC CLI and my cluster in general. So if I do PVC status, we'll show the status of my cluster. So you can see everything's optimal storage and cluster health here. We can show what the primary node is and how I connect to it, and some counts of how many nodes. I have 3 nodes, 57 VMs, 8 networks, 6 OSD disks, 1 data pool, 291 volumes, and 1 snapshot, which is probably junk. 3 of 3 nodes are ready in run state, 57 VMs are start, and 6 OSDs are up and in, so everything is looking healthy. And you can also notice here at the very top, there's this kind of debug output that shows what cluster you're connecting to, the host, the scheme, and an API prefix for the version. So this CLI tool is actually able to connect to various clusters and manage them. I'm not going to show that because there's sensitive information in that particular output, but it's possible to actually take one CLI instance running on your system and actually connect to multiple server clusters. So the next kind of thing, we can show all of our nodes. So I can use help here because it's a click CLI and actually show all the available commands. So there's lots of stuff you can do with a node, but if I do the node list, I'll show my 3 nodes here. I'll show that, they're all running the latest version, which is 0.9.60. We got the states here, so daemon is the state that the actual PVC daemon's in, and they're all running right now. If they were like stopped, they'd be stopped and shut down and all that kind of thing. The coordinator state, so I didn't really touch into this in the architecture, which I probably should have, but with a 3-node cluster, all of your nodes are going to be what are called coordinators, which are the nodes that actually run all the databases and all the kind of core cluster stuff. But if you scale up, eventually you hit a point where you don't really want new nodes to be part of, say, the Zookeeper cluster, because at that point you're just like trying to manage state amongst like 5 or 7 or 10 different database servers. So we have the concept of coordinators where you have some subset of nodes, at least 3, probably between 3, either 3 or 5, because it has to be an odd number for quorum. And those are your coordinators where you actually store all the databases. And then you could add additional nodes on top of that as hypervisors that don't do the database stuff. But 3-node clusters, which is so far all I've ever deployed, both in production and my lab here, all of them are coordinators. And then this kind of has a sub-state where there's a primary, which is the node that's actually the master of the cluster. It isn't special in a lot of things, but it is special in that it runs the API, and it's doing a couple of specific single instance things. So one thing that the cluster does is it does DHCP for all those managed networks, so that only runs on the primary, and then the other nodes will be secondary, and that state can also flip around the cluster at will. Last state is the domain state, which is just whether the node is able to run VMs or not. So these are all ready, but you can use that to say use this flush command to take a node out of service, and that is one of the main kind of like design features that I put into this, was the idea that, hey, I want to be able to like take a node down for maintenance, and you have the ability to tell the cluster, hey, I just want this node to not be in service anymore, and it takes care of looking at the cluster. You tell it flush, and it looks at it and goes, oh, I'm running flush hypervisor 3, I'm running 20 VMs, I have to figure out how to get rid of those, so it'll live migrate them to the other nodes, and it picks the target based on which node has the most free RAM and all of that sort of thing. So it really is, you just give it a command to do something and it figures out how to do it. And of course, you can, flush it, get all the VMs off of it, reboot it, and then you can unflush it or ready it. They do the same thing. And, other cool stuff, you can like show logs of the node. So I could actually show like log-f node HV1, and it'll actually show, oops, I meant to type node, not VM there. So you can see here like the node logs, and this is part of how nodes in the cluster are actually kept healthy, and how it's able to detect that, say, a node's crashed or gone down. Is every 5 seconds there's this keep alive message where both the node is checking into the cluster and kind of updating a key to say, hey, I'm still alive, and the peers are able to look at that. When they do their keep alives, the peers are able to look at that key and go, hey, this guy hasn't checked in like 30 seconds. That's too long. We're going to start a fencing process now. But it also updates, all this information about the node itself into the cluster, like how much RAM it's using, what the system load is, all that kind of fun stuff. So it's actually able to have effectively live stats, and you'll see like if I run this node a few times, 5 seconds apart, these numbers should actually change, very slightly. Yeah, I use memory changing a little bit from run to run there. So yeah, that's kind of how nodes are laid out there. Next I can show networks. So and again, like this is all a pretty unified interface. I use consistent naming and everything. Like it's always going to be list to show your list, that sort of thing. Try to make it as easy for an administrator to learn as possible. And here we can see, my various networks that I have connected into this hypervisor cluster, and their VNI, which is either a VLAN ID for bridge networks or a VXLAN VLAN ID effectively for the managed networks. Descriptions, type MTUs, whether there's a domain for managed networks, and whether there's a DHCP and IPv4 or IPv6 support for those managed networks. So said bridge networks are just like a VLAN bridge down into like a VLAN on your switch, versus managed, which are like a VXLAN virtual network between the nodes. And this sort of provisioning network here is kind of one of the main uses of a managed network, at least in the base case. So you can have like a provisioning network when you create new VMs, so that you don't really have to worry about figuring out what they're what they're gonna do on boot. Like, oh, how do I fix the chicken and egg problem of like setting a static IP when I don't even know what this thing is? Well, you can just have this provisioning network with DHCP enabled, and it just checks in, gets its user data, and then goes, oh, I should be this, and configures itself, that sort of thing. So next up I'll show so the storage. So we got my OSDs here. Again, just accidentally typoing and showing the benefits of the Click UI, having all this integrated help everywhere. It'll always be able to show you what, if it doesn't know what you're talking about, it'll show you help, or if you give it -H, it'll give you help. But yeah, if I list my OSD disks here, you can see the 6 800 gigabyte SSDs that make up my cluster. There's two in each node. So there's the 2 in Hypervisor 1 and Hypervisor 2 and Hypervisor 3. There's some cool things that you can do with the block devices too. So of course you give it a block device, but you can also give it a separate block device for doing the Ceph Blue Store journal and metadata database and all that stuff to help improve performance if you've got like Optane drives or something crazy like that. We got states here, so they're up and in, which means they're good to go, and details of how big they are, number of placement groups. This is all Ceph specific stuff that is pretty much entirely abstracted away from the user while using PVC. But key indicators here, how much used and how much free space there is in each disk here, and the utilization percentage, and some live, how much data is being read and written. Cool stats you can get out of it too. And then of course I can do my storage pool, which shows my VM pool, utilization and information about that one too. And lastly, this is going to be a heck of an output, so I'll just show the beginning, but you can have like these lists of volumes and how big they are, and some additional features on them if you wanted to set that. So because of alphabetic ordering, this is some of my old archived VMs here, but as you saw above, I had 271 different volumes, so each VM has like separate disks, a var, like a root, and then a var, and then a log, and then a serve, and that sort of thing. Alright, so that's pretty much those kind of core pieces of it. So of course, now on to the big show. First I'll show what all the VMs look like, and there are quite a lot of them. So I'll just kind of scroll up a bit here. So yeah, here's the list of all my VMs, and they're all named. They're all in start state. You can give them tags within the PVC system to just help administrators figure out what they are, and that I just have like the OS version tagged. You have kind of your resources here, networks, which is what networks they're in, your RAM and vCPU allocation. So you can see I have a wide variety, all the way from like a gig of RAM up to 16 gigs of RAM, and like I think there's one in here with 1 vCPU. Yeah, Ombi only needs 1 vCPU. All the way up to I think 8 is the most number of vCPUs I have configured. And of course you can see what node it's currently on, whether it's migrated or not. So like I can actually show here, like I can use the migrate command to like move migrate and move are different commands, and they do different things. Migrate's temporary, move's permanent. But I can migrate a VM. Let's say I want to move Web 3 off of, it's currently on Hypervisor 3, and I just want to move it to Hypervisor 2 real quick. So I can just migrate that, and then I can list Web 3 to just show that one VM, and we can see it's in the migrate state, and it's going to HV1, which is what I told it to go do, but it's migrated from HV3, and it retains that knowledge of where it came from. And then now it's running on HV3, or sorry, on HV1, and then I can actually reverse that, just unmigrate it, and it'll migrate again, but now it's going back to 3, and There it is, start. And if I go SSH Web 3 uptime, 17 days uptime, it was all live. It just moved it across the nodes without any downtime. Probably less than half of a second of actual impact for that whole thing where it, finally did the pause and then unpause. So yeah, that's some of the cool features here, and of course, there's a lot more management of VMs that you can do here. You can set like metadata for a VM, and you can, get the XML configs. You can dump it. You can import it. You can manually define a VM. You can set, your RAM, your vCPUs, your add and remove networks, add and remove other devices. Go through the various states, start, stop, shut down. A cool aspect of PVC is that if a VM actually crashes, because you're not actually editing the state in PVC, PVC looks at it and goes, this VM should be in start state, but it's not running. Start it back up. So it actually prevents, within 5 seconds, it'll prevent or it'll restart a crashed or failed VM. Nodes, the fencing aspect takes a little bit longer, up to 60 seconds to really decide that a node is dead and that it needs to be rebooted, but that's something it does as well to keep everything healthy. The last kind of thing to touch on is the provisioner. So this is a whole complicated subcategory of the software and of the tool. That was one of the last things I really wrote to it. But this kind of gives you the ability to set these kind of profiles. So basically how it works is there's 3 different categories of templates. So you can have a system template, which kind of defines your what is my CPU and RAM count, what is my console access, serial console versus VNC console, that sort of thing, as well as some meta information. And then you can have storage templates, which define what disks go into a system, how big they are, what their file system will be, whether they should be formatted or not, that sort of thing. And then lastly, networks templates, which kind of define what network interfaces should this VM have, what networks in the cluster should they be put into, whether to do some custom MAC address profiles if you need static reservation, custom MAC addresses, that sort of thing. So you create these templates, and then from those templates you can actually build profiles. So if I list my profiles here, you can actually see it kind of falls off the screen because I have a apt cacher instance in the way that makes that argument really long. But so yeah, here you can see I'm defining a bunch of different profiles in my system here. So I have this large version of a Ceph FS profile where I use the large system template and a network template that puts me in my Ceph FS network and standard storage and all that kind of fun stuff. And you can see the various different categories here. And then of course you have these arguments that you can provide to tell it what Debian release and what Debian mirror to use, which is on my own apt cacher instance. And last but not least, there's kind of this this data part here, which is really the coolest part of the provisioner, which I touched on briefly earlier, at least I think. We have these scripts which are custom installer scripts, so you can actually do, I have proof of concept scripts for I think 4 or 5 at this point working implementations. One of them is importing an OVA file, just a generic VMware OVA package. It can import it and run it. I have debootstrap for Debian or Ubuntu-based installs. I have rinse for FreeBSD for CentOS and Rocky Linux installs. pfSense, it can actually create a pfSense instance and do the initial configuration so you're able to get into it on its WAN interface. All that kind of fun stuff I'm able to do with this script framework, and it's really extensible. Anyone could come in for their own deployment and write their own script to do whatever sort of install they wanted to. And it's extremely flexible, but also very structured, so it kind of is very easy to just jump in and write your own. And then last but not least, another thing I touched on, we have that support for Cloud Init user data. So if you have your script configured Cloud Init in your guest VM, when it boots, it's able to actually pull this user data from the cluster and based on what profile it has when it checks in, it'll be given a specific user data document where you can go in and do anything you could do with cloud in it, in like a cloud system, you can do here. So yeah, that really covers it. Aside from you create a VM with a single command, and that's basically it. So yeah, that pretty much covers the live demo. So let's jump on to the next section. So now we're on to part 2, which is my VMs and what they do. So the VMs in my home lab are roughly divided into 3 categories, so to speak. So first we have the infrastructure services, so that's monitoring, device management, etc. Then we have core services, those are the ones that keep everything else running. And finally we have the applications that provide actual interesting services. So let's discuss each category and what those entail. And I should also mention before we move on that everything from here on out is based on Debian. You probably saw in the last section with the VMs that everything was running Debian 11 Bullseye. And yeah, I run Debian for everything, including my client devices as well. So the infrastructure category kind of has these 4 sections to it. First of all, we have monitoring. So I use CheckMK in its own VM for monitoring all of my infrastructure. And I'll show off a live demo of that shortly to show what that can do for a monitoring interface. I'm a huge fan of this software as opposed to things like Prometheus and Grafana and all of that. I also have rsyslog log aggregation on its own VM, so I'm collecting all the aggregate logs from all the VMs and all the hypervisors and Ceph nodes and all of that into one central place so I can look at them if there's ever a problem. The next category is documentation. So I did have a Confluence instance, but it's currently defunct. I only kept this category for the organization of this page's purposes. I do eventually plan to deploy something else in its place, but I haven't really figured out what yet. There's the management category. So I have the Unify controller for my access points. That's in its own VM. I have Home Assistant for home automation, which I'll go into in a later section in a bit more detail. That's in its own VM. And finally, I have MQTT for inter-device communication within the Home Assistant ecosystem. So that too has its own VM. Lastly, these next 2 are actually in one VM. So I have a ReprePro Debian repository for my custom Debian packages, which is using the CephFS for storage. So anytime I have to build a package myself, I put that in this repo, and then my VMs can just pull it down. And lastly, I have an apt cache or ng Debian cache in order to avoid downloading the same package over and over and over for these 57 VMs and all the other Debian machines in my network. So that basically gives me a way to reduce my internet bandwidth. Okay, so let's quickly show off CheckMK. So I'm a huge fan of this solution. It's got a really, really nice UI in my opinion. It's very easy to use. You can do everything from the web UI. Which I know is kind of funny considering I mentioned in the PVC section that I'm not a big fan of web UIs, but this one actually works for me, and it's something I could use as a basis for how the other things work. So you can see here, I'm monitoring 87 total hosts according to CheckMK, so more than just the VMs. I'm monitoring everything. 3,835 services are in OK state, and there's 2 warnings that we can kind of see here. I have a kernel reboot for my base node, and I also have a service that needs to be restarted on my Jellyfin node. You can see some historical information here. I had some issues that I fixed just before recording this to make this look a bit cleaner. But yeah, I can show off something really cool here if I search for my env host. So this was something I mentioned in the previous video where I had, this environmental monitoring server, and this is where that actually, puts its data, for lack of a better word. So of course, and this also gives a good view of a normal Debian, response to this. You have all these checks that it just automatically does for you. I don't have to think about any of these. It's just collecting, my CPU usage, and I get a graph of it, and my disk IO summary, and I get a graph of multiple different categories and all that sort of thing. File system usage, interface statuses, and traffic, memory usage, all of that. And I also have several custom checks in here that I wrote myself. For instance, this one here, it's like checking, that one's built in, but it's checking mount options. But these ones are custom, so I have this, rack power check here that's basically just pulling data from my UPSs in order to determine exactly how much power I'm using. So I'm using 1.65 kilowatts right now between those two UPSs. So actually less power than I thought the other day. And, I have each one there. More checks, here. This is one I kind of wrote myself as well that checks, whether there's a kernel update pending or any services need to be restarted after package upgrades, that sort of thing. And of course, we list my UPSs here so I can see their current status, charge, battery voltage, battery temperature, all that sort of thing. And if I, notice a problem here, I can immediately jump in it and take a look at it. I got my A, my B, this one was flapping, and my M, which is for the modems. Check whether I'm backing things up in time, etc., etc. Then I can check like another host here. I can check my hypervisor 1, which that search was actually kind of vague. So I have my router hypervisor 1 and the lights out management, the iDRAC for that hypervisor. But if I go to the actual hypervisor, you can see I have 179 services, so it checks quite a lot of things if you let it. So you can see here, I have all of the virtual interfaces, all the VLANs from the PVC node, all the virtual guests, and I can actually drill down, what VM is using what amount of traffic, all of that sort of thing. I have a huge crap ton of Dell iDRAC based IPMI sensors here, all the fan speeds are being recorded, all that fun stuff. Even as much as, where is it here? Yeah, there it is. Power consumption of each host. That's one thing I really like about, not white box, the main manufacturers like Dell and HP, and that they give you information like this in their IPMI. So I can graph that and see, how much power was this system using for, all that time. And I keep going, more mount options. It's monitoring the Postgres cluster, all the databases within it. I'm even checking my PVC state to make sure everything's optimal. And yeah, that's pretty much a quick little overview of how this works. If I go into I can also go into a graph actually real quick here just to show you that these graphs have a full drill down menu. And I think this actually looks even better than Grafana does. I'm actually not a big fan of Grafana's UI. So, if you're looking for a monitoring solution in your home lab, this is a pretty good solution. It is free and open source. It's an open core type program, so I'm just running the free edition, and it works quite well. It does hit a performance limitation when you get to this many hosts and services. It starts to really use a lot of CPU power to process the checks every minute, but it's still well within bounds for what I use it for, so I think any home labber will probably be okay. See all my problems there and all that. And the last kind of cool thing is you can actually manage, you can edit your hosts directly in the web UI here, and I have everything kind of categorized and put things in their place in their folders, and you can set up rules per folder and all that kind of thing. So yeah, that's the last bit of the infrastructure here. So I'll jump back to my slideshow here. The next kind of group of VMs is kind of the core services. So got that out. So the next section of my VMs are kind of the core services, as I call them. So these are the things that the various other services depend on to kind of function correctly. And within this, there's these 4 big categories here. So first of all are the databases. So pretty much everything that I run can use Postgres as its database backend. So I have just a single 3-node PostgreSQL cluster with the Patroni. I'm not sure what to really call it. It's kind of like an overlay for cluster management. So what Patroni does is, and I did touch on it briefly because we use it within PVC as well. Basically, it allows you to create Postgres instances, and then it uses actually Zookeeper or etcd or one of those other kind of key value redundant stores to manage those Postgres instances and auto configure, this one's the leader and these ones are the followers. And if, the leader goes down, it'll promote one of the followers and reconfigure all the PG-based backup. I forget the exact term for like the streaming replication. And just make sure that they, function as a cluster. And then you just kind of put the fourth category, a load balancer, up in front of it, and you're able to just connect to a single IP and get this redundant Postgres cluster in the back end. So this 3-node cluster, and by node I mean VM, so 3 VMs, and that provides a total of 9 databases for my other services. I don't get into the individuals, but there are 9 of them. So next kind of service here is LDAP. So this is another 3-node cluster. Again, 3 VMs. So it uses Open LDAP with the sync REPL replication. So it's actually multi-master, but I don't really write to it that much. It's mostly just read-only. And this provides the authentication, authorization, and whatever the third A is, backend for all the other services. So as much as possible, I try to tie services into this LDAP database. So if I create a user for, say, like a family member or a friend, they're able to just log in, single sign on, all the services with the same username, same password, all of that. Third core service is DNS. So DNS is actually kind of the largest core service. I ultimately have a total of, excluding my, wow, there's an error here. Aside from, some of the bigger like application services, this is kind of the biggest like group of things. So it's Power DNS with kind of 3 classes of hosts within it. So I have a single PostgreSQL backed supermaster, which is my like NS0 VM. So that's the one that's actually reading and writing to the database. If I have dynamic DNS, that gets updated and it's pulling information out of the database in order to form the zones and all of that. Then off of that supermaster, I have a set of super slaves. So the typo is that there's actually supposed to be 2 local and 3 remote super slaves, not 2 remove. Copy paste fail there, I guess. And the 2 local are 2 VMs in my own instance, and the 3 remotes are out in DigitalOcean. And you'll see those 3 DigitalOcean VMs come up again a couple times later on. They have several functions. And those super slaves are basically syncing from this Postgres-backed supermaster all the zone information, so that even if there's an interruption of the database cluster for whatever reason, these super slave instances are able to continue serving DNS. And specifically the remote ones ensure that even if I had a whole cluster outage, like I lose power at my house and all my rack goes down, at least I'm not going to end up with, NX domain records getting cached out on the internet. I still have those 3 remote DNS servers to provide authoritative DNS for me. And finally, the last 2 of the 7 is these 2 local recursive resolvers that I have. So I separate the recursive lookups for all of my clients and all the VMs and everything from these authoritative servers that actually provide my authoritative DNS, and then those resolvers get handed out by DHCP and all of that to do lookups. And those have a cool little override that I set up, whereby I set it so that everything that they request from my authoritative only ever has a TTL of 30 seconds. So no matter what the TTL is actually set to in the zones, it's always 30 seconds, so I can make sure that my stuff gets up to date. Technically, that's not a standard compliant thing, but since it's for my own internal network, I don't really care. Finally, the last core service is the load balancers. So I have HA proxy in active backup pairs with a keep alive D-based VIP address that floats between them. So the idea being, one can go down and the other one just takes over. And I use HA proxy because I find it the most feature complete proxy. Like Nginx is great as a proxy, but HA proxy can just do a lot more. Like it can do arbitrary TCP services and stuff like that Nginx can't necessarily do. And it's got, I think, better monitoring and visibility into it. So I have 3 pairs of those load balancers. So the first one is for the internal services, which is basically I say DNS and LDAP as well as the databases, the patronis behind this too. So basically everything in this core category is in that internal load balancer. Then I have external service load balancer pair, which is for all of the applications, except for the third, which is my Matrix and Synapse load balancer. And that's kind of separate from the external service load balancer because the sheer number of rules you need to create to make a Matrix Synapse load balancer was just like making that one config too unwieldy. So I was just like, 2 VMs isn't that big of a deal, so I just made another pair of load balancers for Matrix Synapse, and then they can just run on their own. Okay, now we're into the kind of third tier of VMs, which is all of the applications. So all of that previous stuff was just infrastructure to support all of these. So I do host a fairly wide range of self-hosted solutions to avoid dependence on large corporate, big tech, quote-unquote, products and services as much as I possibly can. This whole quest with my own home lab, I had done a lot with lab and kind of, learning things, and also just, storing data in my house for quite a while before. But in 2013, I had really started my career, and the thing that really pushed me to do less of a lab, more of a actual production deployment was Google announcing that you could no longer use your own domain for free with Gmail. And ultimately it took them years, and I don't even know if they ever went through with that, but they announced it, and I said, well, you know what, I'm running mail servers at work, I can run my own mail server. So that was kind of the first thing I did, was move off GApps for my mail, and for a few of my other things using I had used Dropbox and SpiderOak before that for file syncing. So I set up a GNOME cloud, and it just kind of grew from there. And here we are 9 years later, almost 10 years later, and I have this 57 VM cluster that runs all these services, so I can just completely avoid as much as possible these third-party big tech things. So I mentioned here, and I mentioned it when I talked about LDAP, that everything here is available with LDAP shared auth for my family and friends. So somewhere, depending on the service, there's somewhere between 4 and 14 active users. Some things get more use than other things, and it's not necessarily the same people who use the different services, but it's all there for me. And then it just happens to be that make a email account for my parents, or make a chat account for my friends, that sort of thing, and everyone gets on this self-hosted train. So the first application, and these are both in order of use and in order of size to some degree. So first up is Matrix Synapse, which is federated chat and voice video calling. So this is kind of one of the other really huge pieces of infrastructure that it was, I say it in the third point there, it was so big it needed its own set of load balancers even. But yeah, this is kind of the biggest service I run in terms of complexity. And I decided to be a masochist and run a redundant setup, which is not officially supported, but you can figure it out if you read their docs. And I do plan to eventually have a blog post going through how I set all this up. But the main goal of this one, so being federated chat, it was my friend chat solution to avoid other services. We had used Signal before that, but Signal's a pain. You can only access it on your phone or in a Chrome web browser. I couldn't use it with Firefox, and notifications on the phone were a pain, and this and that. And we had tried some other solutions, we used Rocket Chat for this purpose for quite a while, but Rocket Chat ended up blowing up on me more than once, and I finally said forget about it. And I actually moved to Matrix Synapse because of Jellyfin. Being the project lead of Jellyfin, early on we chose Matrix Synapse as our kind of chat for that project rather than using Discord or something else. And I already had this instance running just for my Jellyfin chat, and then it became, hey, Rocket Chat died, let friends get on Matrix. And it's what we've been using ever since, and it works very well for that. I might also say it provides multi-device access, which was a big feature point for me, at least, to be able to just seamlessly move from my laptop to my phone and back. and have all my messages there and just continue a conversation regardless of what tool I'm using. So it's a partly redundant distributed Synapse setup with 6 VMs, hence why it's so big. And I say partly redundant, and that's Matrix Synapse's fault. There's some services within the cluster that just can't be made redundant, which is super annoying. They've been slowly reducing that number, though. There's been, as versions go on, there's been fewer and fewer of these single instance ones, and they all just get lumped into this generic worker. But for now, it's still not quite redundant. So yeah, there's kind of these 6 VMs. So the first is the Synapse 0, which is the primary non-redundant worker and master server. It has stuff like the media store, which uses CephFS on it, as well as the main coordinator. Then I have 2 worker VMs. So they just do various tasks within the Matrix Synapse, setup that can be split out into separate workers. And they don't really, most of their documentation doesn't really focus on running these on multiple VMs. It focuses on just splitting the processes so you can make use of a multi-core system. But I figure, if I'm going to do that anyways, I might as well have multiple VMs. The overhead isn't that bad and makes for easier management in some ways. Next, we have the 2 element front ends. So those are on their own systems as well. Just to keep them separate, and they just run under Nginx. They're not particularly complicated, just like a web root sort of thing. And then last but not least, I have a Jitsi instance for the audio and video chat, which works on its own, but I've never been able to properly integrate it with the Element clients, which is a major drawback of them doing things the way they do. They kind of force you to use the centrally hosted Jitsi, which is kind of against the whole point of a federated chat service, but they do what they do. But I do have my own Jitsi that I can use for various, just if I want to have a group chat with the friends over video or something like that, we can all just connect to that. Next big service, this is the other kind of huge one, is to continue the meme, the Linux ISO playback and request system. So it's Jellyfin, Ombi, several of the R projects, and then Deluge. So all these are on separate, single instance VMs, of course. Jellyfin for the playback and management of the library, and of course, being the Jellyfin project lead, I definitely eat my own dog food there. That's why I, created that project in the first place. It used to be MB, and then we forked, and it was Jellyfin. So I use that. I have a few people, like my family, has access to that, but for the most part, it's mostly for me, because I do not have the internet bandwidth or the legal license rights to stream Jellyfin videos over the internet. I do transcoding for the for the Jellyfin environment using NVEng on my base server using another of my own little projects called RFFmpeg. So that's able to just do the transcoding on a different server than where Jellyfin's running. And I do that transcoding because because of my slow internet connection, I cap the remote streams at 6 megabits a second, and that forces transcoding for most of my very high quality Linux ISOs. So next service, I use Ombi for requesting new ISOs. So if my family has a request that they want, I want to see this thing, they can submit it for their consideration here, and I'll approve it and get it and obtain it and put it in the library. Next up, we have the Rs. So I'm using the 3 radar, sonar, and LiDAR in particular. Those do the search and quality profiling for me. And then they pass the downloads on to the next thing, which is Deluge. So that actually does the downloading. It's BitTorrent. And the combination, or actually I'll do the next one first. And then last there's custom scripts. So when Deluge finishes the download, it runs another of my projects, which is called Media Sorter, which is just a it's an alternative to FileBot, and it just kind of takes the terrible names you get from various downloaded Linux ISOs and turns them into nice names that are human readable and sensible for use in a tool like Jellyfin. And there's also some bash script wrappers, and that does the completed download handling. So what all that enables is my no-touch ISO requests, as I'm going to call it here. So, I'm not even necessarily involved. If someone wants something, they can just go in and request it, and it shows up in some amount of time. And no one's bugging me to say like, oh, can you get this and this and this? So that's that whole environment. And I don't mention it there, but this is actually the biggest user of my CephFS, of course. All those high-quality Linux ISOs take up a very large amount of space, and that is, 98% of what is stored on my cluster. Everything else is, like, tiny compared to this. So next kind of service, it kind of ties in here with the previous ones, but I do keep it separate, is the H5AI file browser. So it's a very nice web interface to a file system. It's got this really nice UI to it that makes it really easy to find things and just browse around. And I use that to provide user access to the bulk data. So of course this is all authenticated, like this isn't an open directory or anything like that. But if my users say they like a Linux ISO they were watching on Jellyfin and they want a copy of themselves, they can just download the raw file. And that's itself a redundant VM with 2 setups, accessing the CephFS storage, of course, and they just run under Apache. Okay, next one is OwnCloud, which is file synchronization and backup. So this one's pretty straightforward. Everyone knows what OwnCloud is. So it's a redundant setup with 2 VMs, Postgres backend, and CephFS for the actual data storage. Now, one of the biggest questions that will probably come up from this is, OwnCloud, why aren't you using Nextcloud? And pretty much 2 reasons. Number one is inertia. I had OwnCloud set up and running with myself and several family members for their backups and all of that, long before, like a fair while before OwnCloud was forked into Nextcloud. And just that inertia of not wanting to deal with because they made their clients incompatible. Like if they had made their clients compatible with each other, I wouldn't have cared. I would have probably switched or tried to switch. Second point. But they didn't, so I would have had to go through and, okay, everyone's phone, new version of OwnCloud, or switch from OwnCloud to Nextcloud, and everyone's desktop will switch that over. And it was just enough work that I was just like, why bother? OwnCloud did well for me, continues to do well. And the other reason was I found some major bugs in Nextcloud that completely preclude it from working with my service. I've never been able to get, and I've tried more than once, never been able to get Nextcloud to actually talk to my LDAP instance. It's a bog standard open LDAP instance. They fully advertise and fully support, and it looks the same as OwnCloud, that they can connect to it. But if I try to connect, it just throws error after error after error. And I never figured it out, and I was just like, well, that right there, that's enough of a roadblock that, I'm not going to go through the effort of replacing what I currently have with that, because, it works, just keeps working. Right, next thing, I have Git and another of my own projects called Basic Builder, which does my development in CI. So I have a standalone Git VM. I used to have a GitLab, but that was held to upgrade. And after a very failed sequence of like 9 upgrades that failed halfway through, I kind of gave up and moved to Git, which has been working seamlessly ever since. And, I had used GitLab CI, but I just did the most basic stuff with it. So I built my own tool called Basic Builder to just basically run basic shell commands in response to CI. And that runs on its own VM as well. So this does pretty much 2 main things for me. I do a lot of, code development. Obviously, I have my projects like PVC, these Basic Builder, and the previous one I mentioned are FFmpeg and Media Sorter. So this is where I put all that, those Git repositories, and it does CI for my websites. So I actually have a setup where, and I'll kind of briefly touch on it when I get to those, but I have a setup where, if I push an update to my personal blog, it's just in a Git repo, and it's Hugo-based. So I push the update to Git, and the CI runner just, compiles the Hugo site and uploads it to the web servers, and bam, my site's live. And I have the same idea with several packages that upload to the repro repository. I just push up new versions of the code, make a new tag, and it'll build the package and deploy it out for me, and then it's available in my repository. And the next one is actually a fairly old and then new addition. It's Mastodon, Federated Social Media. So I have a pretty basic but redundant setup with 2 VMs, Postgres backend, CephFS storage. I originally set this up, gosh, like 3 or 4 years ago, when it first became a big thing that people were, talking about. And then I ran it for a bit. I was like, well, no one's on this. I don't follow anyone on here. I tried to get a few friends on it, but they were all Twitter users. Foreshadowing. They were all Twitter users. So eventually I just kind of said, I don't use this. I'll just shut it down. And then sure enough, in December, Elon Musk and his Twitter, chaos, suddenly Mastodon was relevant again. So I spun it back up. Took about like 10 minutes because I had already done all the work. And bam, I'm back to having a Mastodon instance. I don't really use it much myself, but I have a couple friends who do. Okay, another big one, but this one's getting more into the, less used by other people, more used by me, is my mail setup. So as I said earlier on, this was one of the first things that really got me into self-hosted, home production type setup, was wanting to run my own mail. And despite this being the number one thing that people say, oh, don't self-host yourself, I've never had a problem with it. I found Mail to be one of my most reliable set it and forget it type services all throughout the years. I've never been blacklisted. I've never had problems. Even when I've changed IPs, had to build reputation up again, that sort of thing. I've never had a problem with it. I'm not exactly sure. Maybe it's because I have more experience running running ISP grade mail for people. Maybe it just, there's pitfalls that are obvious to me that aren't to other people, but I've never had a problem with it. So I say, if you're thinking about it, try it. I mean, it can't hurt. So my setup's based off of the kind of standard suite. So it's Postfix, Spam Assassin, ClamAV, Dovecot, and then RoundQ, which all together provide the email. So there's kind of two sides to it, right? There's the access and storage side, which is the Postfix, the Dovecot, and the RoundQ. And that's a redundant setup with two VMs. It uses LDAP for the authentication authorization, Postgres for the database backend, and CephFS for the storage. Standard pattern there. And that's what gets me access IMAP, RoundQ webmail, etc. As well as of course storing the mail on the CephFS. And then there's the inbound filtering. So this is actually done on my remote servers that I had mentioned before, back when I was talking about the name servers. These would come up again. So I have these 3 DigitalOcean remote VMs, and they're actually what's handling my inbound filtering. So my MX records for all my domains aren't actually in my home lab. They're on VMs I control out in the cloud, so that if, again, I have like a full outage of my home system, I can at least queue the incoming mail on servers that I control, so when I come back up, I can go in and, make sure those actually delivered, because I don't want to lose emails, of course. And all the filtering there, so that's the Postfix, Spam Assassin, and ClamAV side of it, so that's done there. And then, of course, outbound, also, and this is an important point that I think people miss when setting up email, and why it might be causing them problems, is always make sure, you're authenticating your users, but you're also doing spam filtering on the outbound. That's huge. So outbound on the access storage VMs, I'm doing the same filtering that an inbound message would get an outbound message has. So Postfix, Spam Assassin, ClamAV. And that makes sure that if somehow one of my users got compromised and they started sending out spam, it would get blocked before it ever left my servers. No reputation hit. Okay, next up, Apache, which is websites. So this is another redundant setup with 3 VMs. And this is using that basic builder CI, and I mentioned I have Hugo static sites. I have a couple of my own. I have at least 4 websites that go here. I have a friend with at least 1. I think that's it. But they're all Hugo sites, and then this CI builds the Hugo site and then pushes it using rsyncd to all 3 of those web servers. So they're always kept up to date. And then I have a second layer to that where we're back to those DigitalOcean VMs again. The 3 of them, they actually act as a remote caching Nginx instances for the websites. So the idea being, if my home network is down, those caches are valid for, I believe I have it set to 12 hours. So they'll always serve at least, might be a slightly old if I pushed an update version of the website, but they'll keep the website going for at least 12 hours if my stuff's down. And if my stuff remains down, I can always, up that cache level and just reload the services if I need to. Okay, and this right here is the last of the applications. So, kind of two categories of the same thing, but it's games. So I do host 2 game servers myself. Again, each on their own VM. So first is a Minecraft server. I've never played Minecraft myself. I'm not a fan of it, but I have several friends who do. And this evolved from, one of them had hosted it in a small box in his basement, and that box died. So he said, hey, can you run it in a VM for me? And I have ever since. I don't think it gets very much traffic these days, as everyone, works and got older. But it's still there, still running. It's got a pretty large world, I know that. And then I also have an Unreal Tournament 2004 instance, which is a very old game, but it was a LAN party staple amongst my friends for years. So after our last really big LAN party, probably like 6 years ago, I took the VM that I was using as our dedicated game server and just put it on my cluster, and it's been running ever since. I think we've used it once or twice ever since, but it's there in case we need it. Sometimes I'll shut it down for like days or weeks at a time if it's annoying me, but generally it just sits there. Fun story about that. If you leave a dedicated server running for hours, like not even hours, for weeks and weeks and weeks at a time, eventually the bots, like in a deathmatch, eventually the bots just freeze and stop. It's like they know they're in a simulation, and there's no point in killing each other for the 100,000th time. So, yeah, we saw that once and had a bit of a spooky moment. And now we're on to the last one here, which is game streaming. So technically this isn't a VM, but it's another service within my house, and this is in my own house only. This is just for me. So on my base machine, I have set up an NVIDIA GPU, a 1660, and I use a tool called Sunshine, which is a flawless implementation of the NVIDIA Game Stream server, and I use that to actually stream a desktop environment with full GPU acceleration to my clients. So that GPU is pretty decent. Gives me good performance in the games I play, which aren't very many. Mostly, Skyrim. I actually play 3 games. I play Skyrim, Civilization 6, and City Skylines. But for those 3 games, that 1660 is plenty. And then, as I said, I stream them to my laptop where I use the Moonlight game stream client there. So I get actually high quality and very good performance, even over Wi-Fi, for streaming games just inside my house. And then that way I'm not, killing my laptop's battery and producing a ton of heat on my lap, and I get much higher quality out of this remote setup. And it's all on hardware that I had running anyways. That GPU I bought for hardware transcoding to do Jellyfin transcodes, but then it turns out, hey, well, people aren't watching videos, I can just play games on it. And that base machine is pretty beefy just to do desktop and the cloud stuff, and it's like, hey, it can run games too. So that was really that. So next part here is home automation. So I'm just going to give a quick little overview of my home automation setup, which is another of the kind of core services that I run. I had mentioned it back in the infrastructure part of the VM list, but I do some pretty cool things with this that I just want to share as part of this whole, server infrastructure setup. So, say here, I'm using it for various home automation devices. I have various smart plugs, switches, and dimmers to control lights and small appliances in my house. It's mostly Belk and Wemo, for which I have both plugs, switches, and dimmers. And I also have some TP-Link Casa plugs that I've been buying more recently. They're cheaper and actually perform a fair bit better than the Wemos did. So I'm slowly replacing things with those. I also have a bunch of ES-Presence ESP32 boards at strategic locations in my house to do Bluetooth LE presence detection of my phones. They also have, some of them have PIR motion sensors and temperature sensors for the environmental conditioning monitoring within my house. And then lastly, I also have a Calliope, which is an open source voice control solution on a Raspberry Pi in my bedroom, which I do have a previous YouTube video kind of demonstrating that and a blog post about it, but basically lets me do fun things like laying in my bed and going, computer, lights off, and it turns off the lights in my room. So I have 5 main zones within my house for the home automation and the various things they control here. So I have a garage zone, which has a heater, which is right now keeping me very, very toasty out here. And that's kind of the only thing out there. I don't want the lights automated. I have a backyard zone where I'm controlling my gazebo lights, fan, and also probably eventually a fountain. And as well as garden lights, which I have like solar powered garden lights that I control via Home Assistant, as well as I had previously built a sprinkler control system that's currently defunct, but I do plan to rebuild it this year when summer comes in order to water my gigantic garden automatically. Next zone is my bedroom, where I just have light control with the voice control aspect as well. In my basement, I have kind of two main areas down there where I'm doing light control, so both the overhead lights and a light at my desk, as well as some appliances. So I have like plugs on my desk that I can control with Home Assistant. I have my 3D printer connected to Home Assistant, so the clipper management tool can turn it on and off. And then I have like a fan for my drumming on a Home Assistant, so if it eventually I'll set it up so if it detects that I sit down at my drums, it'll just turn the fan on automatically. But for now, I just press the button. And the last kind of zone within Home Assistant is infrastructure. So I actually have all three of my WAN modems on smart plugs, so I can do a quick remote turn it off and on again if I ever need to. Thankfully, that doesn't happen very often, but it's there just in case. So this is kind of the cool thing that I want to talk about. Is this was actually a recent implementation that I haven't quite finished the blog post on yet, but I figure I'll talk about it. So I have ES presence detection in 5 key areas of my house using those motion detectors. So the garage, motion and presence, the bedroom, motion, presence, and voice, the basement, a desk area, which is the first side, is motion and presence. I have my TV room, which is not a separate room, it's just an area of the basement. That's for motion and presence. And then finally I have on my main floor, I have kind of a control location to delineate the other locations. So as I move from, say, garage to basement, I'll pass through main floor, or garage to bedroom, I'll pass through main floor. So it'll always, accept that, oh, I've left that previous zone, and then enter the new zone. It doesn't really flap between them. So some of the cool things I'm doing with this, best example, so the heater control in my garage. I have it set up here, so this PIR sensor and the presence detection, basically what it lets me do is I have a PIR sensor pointed at my garage door, so when I open the garage door, detects motion, that'll fire up the heater, and the heater is actually controlled by both a smart plug, and then it's a heater unit with a remote, so it needs an IR signal to actually turn it on. So I just used another ESP8266 to build a little IR blaster and send the commands to it. So when I walk in the garage, it turns on the smart switch, I hear beep 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 as it turns on the heater, and then my heater's running. And then in reverse, when I leave the garage zone, it'll both no longer detect motion, and it'll also have the presence detection detect that I've left the zone. So when those conditions are true, it'll turn off the heater. So that way, I don't have to worry about, moving in the room. As long as I'm in there with my phone, my heater will stay on. But as soon as I leave the room, my heater will turn off. And, it's just like all home automation. It's just one less thing to ever have to worry about. It just works. Whenever I walk into the room, I have heat. And whenever I leave the room, I don't have heat. And it's off, and I don't have to worry about it. And this actually ties in that temperature sensor, so I have it configured so that it actually won't turn on unless it's below a certain temperature in the garage, which I think I've set to 12 degrees Celsius right now. So once it gets cold enough that I kind of want heat out here, it'll turn on. But during the summer, this whole thing can stay set up, and it just will never trip because it won't be below that temperature. And I'm doing that same sort of thing everywhere else. So bedroom, same idea, only just with lights instead of a heater. If I walk into the room, detects motion, lights turn on, and then the Bluetooth LE present says, hey, I'm still in the room, so don't turn off. But then for that one especially, I still have the voice control, so when I'm in bed at night, I can say, hey, turn off the lights. And then I also have an automation set that if my phone is in a particular, like if it's charging wirelessly from my particular bed and it's within X distance of that sensor, it knows I'm asleep and therefore will turn off that motion detection. So my lights won't just turn on because someone walked by to the bathroom outside my door or something like that, or opened up my door. And then again, same idea, basement desk, motion and presence for a light, TV room, motion and presence for a light, and then that control location doesn't actually have a motion detector, it's just for that LE control. So yeah, that pretty much covers my home automation. Something pretty cool. Maybe I'll expand on this a bit more if there's interest. And yeah, that's it for that section. And now on to the last section of the video here, where I talk about the WAN setup. So I've mentioned a couple times in the last video and in this video that I have 3 WAN connections. I have an extremely complicated WAN setup, and the whole purpose of this is to provide a virtual presence of my home lab as if it was in a co-location. And I have the redundancy I'd expect from a colo, even though I'm just on a bunch of residential internet connections. So I have 3 internet connections here on 3 different physical mediums. So I have DOCSIS cable, which is kind of my primary connection. It's a gigabit down and 50 megabits up, which I have to pay extra business connection to get that fast of a speed. I'm really hoping that someone will someday run fiber to my home in the suburbs, but I don't think that's going to happen anytime soon, so I'm stuck with terrible upstream. The second connection is a fixed wireless LTE that I just got installed last year because that became available, so that's 25 by 10 megabit a second. And finally, I have DSL, which is 25 by 10 megabit a second advertised, but I actually only get about 20 by 5, and that's because, it's 50-year-old wires, and the phone company has never wanted to dig up the streets and the lawns to replace these wires. Because if they did, they'd put fiber in these days, but they have to dig up the roads and the driveways, and that's nowhere in sight. So yeah, the goal of this crazy WAN setup was to not run my internet services off my residential ISP IPs. So both the fixed wireless and the DSL change IPs constantly, of course, and the cable is business class, but I only get 3 IPs. It's not enough to run all these services out on the internet, at least not in the way I'd want to. So instead, I have this virtual presence system. So this whole WAN setup's actually gone through 3 phases. Three and a half phases, let's call it that. So phase 1 was my original setup back from when I first started doing mail for myself in 2013 until about 2016. So I have my DSL provider, who's actually a TPIA, so they're a third-party reseller of the incumbent lines. I was able to convince them to give me a /27 static IP block over my residential DSL connection. I still don't know how and why they were willing to do that. Like, it was one of those things where it's like, well, shot in the dark request to these guys, and they said, sure, we'll do it. It's like, oh, okay, I guess I have a solution here. And they also gave me, of course, a static DSL IP. So that ran really well for me for quite a while. I was able to run all my services out of these public IPs on that single connection. And they gave me reverse DNS and everything I needed to make that work. But there were cons. 2 big cons. The first was there was no redundancy to this. If my DSL connection went down for any reason whatsoever, which, next point, then I'd lose all of my service. And of course, it was very poor quality. Not the TPIA's fault, but it's the incumbent's fault because the wires are ancient, the drop is ancient, everything about this thing is ancient. I can't even get the advertised speeds, which are low. Ironically, I've had the incumbent come and send salespeople to my door more than once over the past, 10 years since I've had this. And every time I tell them, what's the max speed you can give me? Oh, we can give you up to 100 down and 25 up. And I'm like, no, you can't unless you replace the wires by and close the door on them. Until they run actual fiber optic cable into my house, I do not trust them to actually make that better. So in 2016, I was kind of like, okay, that was a nice solution, but let's come up with a different plan. And this is where I first came up with this crazy redundant, like this point of presence idea. So what I did is I rented a dedicated server out in from some, I can't remember the name of the provider. It was some low-cost dedicated server provider out of Toronto. So I rented a dedicated server, and they were also willing to sell me a routed /28 block as well. So I just had that routed towards this server. And then I set pfSense on both sides. So on my home side, I had a redundant pair of pfSense VMs because I always do redundancy. And then in the colo, I just had this one server sitting out there, also running pfSense. And then between the home and the colo, I set up an OpenVPN tunnel that routed over my DSL internet. And then on the colo side, I routed that /28 block over the tunnel and then terminated it in the home side. So in effect, that was the very first time I had done this kind of thing where, you establish a VPN tunnel between two endpoints, and then you're just using standard like internet routing, like they're static routes, but it's routing. Just route the traffic over that tunnel, just like it was any other hop on the internet, and voila, I have this public /28 block terminating in my basement that's coming in from this colo provider. Now, the cons of this setup was mostly around pfSense being hacky garbage. It has a lot in common with Proxmox. I'll leave that there. But yeah, if you've ever looked at the pfSense code, you'll know that it's a bunch of PHP that regenerates configurations every time you click a button, and it's absolutely absurd how it works. And I ran into a problem where basically nothing could fail over fast enough. It would take like 30 seconds for it to detect that my WAN went down, and then another 30 seconds to fail over, and like crazy stuff like that. And it's like, this is absurd. And it's because it would be doing like things in PHP. It would be like doing PHP checks of my WAN interfaces and all this stuff. So it was like, this is not good. I gotta replace this with something else. And sure enough, the other part of phase 2 is I was still just on that one DSL connection. It still sucked. There's still no redundancy of my WAN. So that brought me to the first phase 3, where I had version 1, which was my pre-current setup. So this was roughly 2018 to 2022, till last year. So the first thing I did was I moved the routers on both sides away from pfSense to raw FreeBSD, first on the 12.x release train and then on 13.x right now. And then what I did, I ditched pfSense. I re-implemented the entire firewall, NAT, routing, all the VPN tunnels, the DHCP, on the client side, all of that just in raw FreeBSD. I still used OpenVPN for the tunnels, but everything else I picked, a bog standard FreeBSD solution. And there were several that were just like, why is this not used in pfSense? A big one being a tool called ifStateD, or ifStateD, which is able to, every second run a check, or, however long you tell it to. Every, few seconds, run this command to do a check of something. Ping some remote target out my WAN interface, and then if my WAN interface is down, it'll know immediately my WAN interface is down, no 30-second delay. And then I'm able to use some cool stuff in PF, the idea of anchors within the PF firewall, where I can just have this dynamic area that I can insert rules into, and then I'm able to use ifStateD to insert rules, being like, okay, I have my WAN connection goes down. Well, take out the old stuff I had in that anchor and put in the new stuff. And that gets into the next thing I did, which they're a bit out of order. I added a second internet connection. I added the DOCSIS cable internet connection. So now I was able to actually load balance over two internet connections. And if one of them went down, that's where that detection would come in. I'd be able to have ifStateD immediately know, oh, the DSL connection is down. Okay, rewrite the PF rules in this anchor to not send any traffic out that interface, send it all out the other interface. And when it recovered and the ifStateD check would return true, it would immediately start working again. These are things pfSense just couldn't do this, which still to this day it can't do it, and it still boggles my mind. And of course at this time too, I also moved from the rented dedicated server to a co-location with some of my own servers in it. So I did end up one-to-one replacing my old /28 block with a new /28 public block, but functionally nothing really changed. It still worked the same way. It was just my own servers now in a co-location that I was paying, a much larger bill for, but further flexibility. And all that worked very well until last year, where I came up with version 2. So the first thing I did over that time was I changed from OpenVPN, which was very slow. There was major traffic limits over the VPN, like speed limits, to WireGuard, which is much faster. I'm not here, but MTUs suck. I think I finally fixed all my MTU issues, but that was a year-long saga of trying to get WireGuard to play right, because if your MTUs are slightly wrong, it does weird things. I also added a third internet connection, which is the fixed wireless access, which was due to some flakiness I had with my DSL and my cable. I actually had to change cable providers. I was using a TPIA, which I've used that term a few times. It's I don't remember what it stands for, but it's a reseller of an incumbent. So I was using a TPIA cable provider, and I ended up having this huge outage of the cable infrastructure in my neighborhood. It was like a 3-day outage from the incumbent, and when it came back, they had done something. I don't know what they did. Put me on a different CMTS, put me on the wrong CMTS, who knows? But my TPIA would no longer work. I couldn't get DHCP from them, and I fought for 2 months trying to get the TPIA to just admit to me that they couldn't fix the problem because they couldn't see what was wrong, or to use your internal contacts as a TPIA to escalate this to the people at the other provider, and they just kept dithering, and I finally said, you know what, I'm sorry, I know this situation sucks, but I need my internet connection to work, so I switched to the incumbent, and it's been perfectly seamless ever since. Wonder why. But yeah, that was unfortunate. I like supporting that third-party provider, but as of 2 days ago, they got sold to TELUS, so I don't care anymore. They're a huge company now. They're part of the big three now. Oh well, too bad. And finally, I was able, in this version 2, to fix numerous routing bugs and anomalies with the load balancing of my servers between the various connections. So the way I have it right now, the DSL is actually just dedicated to the Linux ISO downloads. That's all it does. And then my DOCSIS and fixed wireless, my clients go out the DOCSIS unless it's down, and then they go over the fixed wireless. And then my server stuff, both inbound and outbound, which I'll show on the next page when I get into the diagrams of how this works, they load balance over the two, but in a weighted fashion based on the speed of the connection. So because the DOCSIS is so much faster, it'll preferentially send connections out of it until it hits 6 or 7, and then it'll send a connection out the other one. So hopefully it balances over aggregate over time, and I found this works very, very well. Okay, so here's a diagram, because this is way too complicated to just explain in words, of the WAN tunnel setup. So basically in my home there at the bottom left, I have a server. This is just an example with one server. Then I have my in-home routers, so they're called DCR for data center router, and I have a primary and a backup. So they're those FreeBSD, PF firewall, and router, and they're the WireGuard peers. So I have my 3 WAN connections, kind of here in the center here. So WAN 1 is the cable, WAN 2 is the fixed wireless, and WAN 3 is the DSL. I still put it on here even though it's dedicated to other things now. And then over those I have the colored VPNs. So VPN 1, 2, and 3. So those reach out over the internet to my colo, where I have that RR remote router, which is running the same FreeBSD PF firewall, and the WireGuard server. So those terminate there, and because you'll see here on my side, I'm forwarding them so that VPN 1 goes out WAN 1 and VPN 2 goes out WAN 2. So that way, even though that these are residential internet connections with no SLAs, no guarantees, I'm able to load balance over them effectively with these tunnels. But then they all terminate back in my colo, which is a much more reliable connection. They just terminate in one main interface. And then from there, those remote routers send traffic back out to the internet. And out here, and this is again just an example, I go out DigitalOcean to one of my remote servers. So that's kind of how the tunnels are set up. This next diagram shows how the traffic actually flows across this, and it's complicated. So I have a legend of the net blocks I'm showing in this example. They're all just examples, they're not my real net blocks. So I have, an RC1918 internal, I have the RC1918 WireGuard point-to-point connection, then I have my a primary colocation public address that the actual servers in the colocation sit on. Then I have my routed /28 public network, and then finally I just use this random example subnet for the DigitalOcean side of the remote VM. So it's basically bidirectional, and this diagram just kind of shows the two directions, but they're functionally the same. So if I'm going outbound or I'm doing a download from the home server side, it's got a local RC1918 IP. It goes to the data center router. It does the NAT termination of that /28 block. So depending on the specific server, it may just be a masquerade NAT, where I'm hiding many servers behind one IP, or I have several things. For instance, my mail servers, they're a 1-to-1 NAT. So they're able to have their own dedicated IP address on the internet out of this /28 block. And I'm using all except for 3 of the IPs right now. So I'm using most of them up, but I don't need any more than I've got, So that's the NAT termination. So from there, the packets effectively on the other side of that NAT in PF have the public IP address on their source, and then that gets routed based on the rules set in if state D that I've mentioned. Those get sent over the WireGuard tunnels, load balancing depending on which one's which. So, I have the two WireGuard tunnel endpoints here, and that's just showing that there's this tunnel with these, virtual IPs over the WAN. And here I have, a public IP in one of the public WAN IPs in my house, and here I have the inbound, a separate public IP on the remote router side. And I do that so that it helps with the ensuring these WireGuard tunnels go over the right internet connection. So basically I have 3 different target IPs, one for each of the WAN connections, and then I'm able to really simplify things on my side and just say, to this IP you go out this WAN, and to this IP you go out that WAN. And that ensures that, those WireGuard tunnels go over the different WAN connections without any, complicated routing rules. They're just a bunch of static routes. So those WireGuard tunnels go over the WAN, and they terminate, on the remote router, where they again hit PF, which doesn't really, I'm not doing any firewalling or any filtering on this remote router side here, just because I do all that on the internal side, but it is used for having some load balancing routes, and for just ensuring that traffic flows where I want it to. So the traffic, comes out of there, and it gets sent out this server RR1, and that goes out over my colo's main connection out to the remote server. And there we go. There's the path from my main server to a remote server over this crazy connection. And in the middle here, where there's the green arrow with WireGuard tunnels and WANs, that's just over the internet. But you can see here, we'll flip to the other direction, where it's inbound or an upload from the server. So this would be someone connecting into one of my services. So you come in from the remote server, and they're going to hit something in this, this 10.0.1.0/28 network. So they're going to come into the colo provider on that network, and the colo provider says, okay, this /28, we route it towards this main public IP on my RR server here. And just for clarity, these IPs are like CARP VIPs between the redundant pairs here, but I don't show that here for simplicity. So this /28 block is routed towards this IP, and then it comes in on my server here, and it the traffic passes in through PF, and it goes, okay, I'm supposed to route this /28, route all this traffic over these WireGuard tunnels. And it works the same as the last in reverse. The tunnels are already established, they're always up. So the traffic gets routed over that WireGuard tunnel, over the internet again, to my house, where that packet, with that destination of 100.0.1.0/28 hits my PF, and it gets NAT terminated. And again, just in the reverse of the previous, the outbound, just in the reverse, it gets terminated with NAT, depending on the exact server that it's targeting, and then it hits the server, and then the replies, go back the same way. And with this crazy setup to the internet, to someone connecting in, they just see I have these public IPs here that are provided by this colo provider, and from their perspective, if they do a trace route to me, they just see that, oh, it hits this server called RR1, and then it hits the target. And that's it. They don't get to see that all of this stuff on this left side of the diagram is in my house. It just looks like it's in the colo provider. So I don't know, I always found that really cool, and it helps abstract those residential connections away, while also giving me, it gives me the power to have all this stuff in my house and not in some colo like 50 kilometers away from me that I can't get to easily. It's in my house, it's right there, but it looks to the internet like it's in that colo, and that I think was the real goal for me for this setup. So that wraps up my my video here. This is going to be quite a long one. If you got all the way to the end here, I thank you very much for watching the whole thing. Hope you have a great day, and if you haven't yet, subscribe to this channel. I mean, I've made more videos on this channel in the last 2 months than I did in like the 5 years before that, relatively speaking, time-wise. So we'll see where things go. Maybe I'll make this a regular thing, and yeah, take care and have a good one.